Perfect. So I started the recording. Okay. So last time when we talked, we focused on the boot sequence coordination. If that's okay with everyone, I think we should pick up where we left off. Last time, I know that some people were a bit out of their element last time, but let's try to narrow down the discussion a bit and maybe set something a bit different for the next discussion so we can have a couple of parallel efforts. Basically, to sum up, and let me know if I'm forgetting anything, but to sum up our previous discussion, we talked mostly about the beginning of the diagram that is presented in the OPI coordination page. We agreed on the fact that XPU management and XPU CPU would also be something that we won't standardize on. That XPU management can be the XPU itself, can be XPU BMC, can be chassis BMC. Basically anything that can provide those PLDM command that we talked about. I started to work on this document a bit to clean it up. I'll share my screen. And let's try, I think, to work on the README as we go along, and maybe we'll get to a point where we can actually push something and create a PR and update it, because doing it offline doesn't really work out, at least for me. Okay. Can everyone see my screen?
Yes.
Perfect. Okay, so what I did here is cleaned up a bit the summary, moved the two other options that we had to an appendix. I know that we said we will pick up the InBand PCIe later on, and it's stated in the summary page. Plus, I have here the second option, which we agreed to not work on, but didn't want to lose the information. Updated the diagram a bit to show that the power is actually a parallel effort. And I did add here something that we didn't talk about, and I wanted to get your opinion on this discovery command part. We did say that we will discover if it's a DPU or not through the full record. Basically, this would be our get inventory. But PLDM also defined a couple of discovery commands to understand if we actually support PLDM, what is the version, and so on. So I wanted to get your opinion on that one. Basically, we have a couple of commands defined in PLDM, get PLDM version, get PLDM types, get PLDM commands. I think that if it is needed, and Lee, folks from servers, let me know if you think it is, then we at least need to discover the PLDM version here.
Yeah. So I think one of the issues with PLDM is that it may be available kind of late. Because just to get the MTCP stack up and running and everything else, maybe available, like with Fru, that's
yeah, it's bundle.
always available, and as soon as you have aux power, but depending on what the entity is that's terminating the other side of MTCP, that may take shorter or longer, like, for example, if you were doing MTCP over PMCI VLDM, right, it wouldn't be available until after you did the PCI enumeration, and we're trying to do this before the PCI enumeration, right? So this is where you can run into some problems.
I see. But either way, we will need it before the get boot status command. Now, what does it even serve any benefit to understand the PLDM version, or do we just want to issue the get boot status command? If it's supported, then great. If it's not, then carry on, as suggested last time.
So it seems to me like maybe we start off with these things as optional, and then, but I mean, again, if you're doing get boot status, then you have to probably do all the discovery. Like,
yeah,
you're ultimately sending everything over PLDM, and you're probably doing all this other stuff too. But you may have to, what you'll probably, well, so yeah, so
maybe we should just switch it to be
okay,
a bit later on in the sequence.
Okay, so again, I think we need to figure out if MTCP is going to be universally available, right? And I think I know Boris has mentioned, and there's some thoughts of there's an option coming up in the Chem 6 or the PCI Chem 6 version that hopefully will get backported to previous versions of repurposing the JTAG pins for USB, and assuming that goes to a BMC, there's there's all these transport things, right?
Yeah, that are detailed here in a sentence. But do we, what I want to ask, because I don't, that's part that I don't understand. What is the difference between those that transports in regards to PLDM?
Okay, so when you're going over the I2C connector, that's on the Goldfingers, that's the PCIe Chem adapter, right? So, and that goes directly, to the platform BMC, right? So it's independent of the system power state, right? But a device will not get full power probably until you start booting, right? You have to turn the server on before you're going to get, more than, I don't know, it's like 5 watts or 10 watts in aux, right? So you obviously can't power a bunch of ARM cores and things like that usually in aux power. So it has to be so the transport's there. PCIe VDM requires the interaction of the root complex, and everything has to be enumerated. So that's going to happen much later. Okay. The USB is referring to, a future option where you could have USB and over the same Goldfingers. So different pins than I2Cs going on. And that would be a higher speed transport over the Chem connector. And whether that would be available in a lower power state, I'm not sure. And then serial is an option sometimes. And I don't know enough about other, but it has been used as a management transport, right? Similar to I2C.
Boris linked here that there is really a work in progress, as you said, to support the USB. Where is it?
Yeah, I know Yuval is working in the DMTF on that thing, right? Yeah.
The question if we actually want to rely on that one or not.
Well, this is Riza. Certainly for the future, we would prefer USB for the higher bandwidth. But we need to comprehend the near term. It's going to take a while, I think, and maybe the DPU vendors need to speak up. When will they have USB available on the Goldfingers? So, you know, that needs to be coordinated in terms of which platforms can support USB on the Goldfingers. What exists today is NCSI, RBT, right? And I2C. That's what exists today. And so we've, you know, how do we draft a spec so that it accommodates what's available today, but is flexible enough to adopt to the higher bandwidth transport layers as they become available?
I'm writing it down because I really like that note. We should come up with what's available today. I'm actually not sure regarding ourselves what is our plans here. Other DPU vendors that are on the call? Anyone knows the answer, or do we need to do somehow to check in house?
Yeah, and it may deal with future product designs that are probably a little difficult to discuss.
I see. Everything. I have to admit, even on the boot sequence, I wanted to come up with this is what we want to promote and support. This is what we have today, and I still don't know what I can talk about, what I can talk about, and have a very, very abstract proposal, basically on what on what Boris stated here. So,
and that's why I kind of stuck to what's currently in the MTCP state thing, and I'm not sure that this is totally if we wouldn't need to define some more states, right, to make it.
I assume we will.
Right.
I assume that eventually we will, but that's why Boris, I think, added here this this chart of PLDM of what exists right now, and we can try and track it and see if that satisfies us or not. He even did us the favor of skipping parts that are a bit not relevant from his point of view.
Yeah. Right. Yeah, we worked on that together.
Oh, so credit goes to you as well.
Well, and actually also Intel had kind of proposed this too, so.
Okay.
I don't want to take all.
Kudos all around. Then. Okay. Wait.
Yeah, so I mean, it's kind of so I don't know if a vote or what, so I guess we got to decide at some point whether if you can certainly do PLDM over I2C, you know, early on without PCIe VDM. And if that's where we're all going to go, if that's what we think is the most likely thing to do, at least for this boot sequencing, I think where you really need the USB is if you're going to do any high-speed communication, like, you know, firmware updates, or, you know, if you're going to do an OS deploy onto the DPU, you're going to need a higher speed connection than I2C, right? PCIe VDM might also be used, but
he said it will come later on in the process.
Yeah.
And that would slow us down.
Right. So just for basic coordination, it's not you don't need to pass a lot of data.
Mhm. Okay, so I think we narrowed it down basically for now. And as Rada said, we should start with what's available today. So I
Mhm.
think those two are the preferred options from what I heard so far.
There's not a lot of
Um,
I3C out there yet. So
that's
it's
why I just do we need to pick one of them?
yeah. Well, just
I really wonder, is it if we need to define it with an OPI, I2C or
Yeah.
I3C? I think
You
we
could
can
say
live with both.
you could say SM bus and that would cover, I think, everything, right? So
There's the NCSI as well. I mean, now,
right.
again, will every vendor have require NCSI? From a platform point of view, NCSI is a little more restrictive in terms of it's not a set of signals that natively runs through the PCI CAM connector, which means that we have to cable up from, either from the motherboard or some other, we have to manually install a cable from one point to another point, which is it introduces another point of failure. It introduces another attack vector, security attack vector. There's difficulty associated with it in the field in terms of upgrades and maintenance and just having an extra cable in there, because the real estate is pretty tight. The signal integrity is pretty difficult in terms of limiting the length of the cable and stuff like that. So, but that's what exists today. Both options that exist today are very slow, and like Lee mentioned, if we want to do firmware upgrades, it just takes a long time.
But for the boot coordination, for this very, very initial part that we are talking about right now, as Lee stated at the beginning, we don't need the high speed.
Right. We don't need the high speed. And so, my inclination would be to say, for now, let's do I2C with enough flexibility to adopt a different protocol as it becomes available.
Also, if you say MTCP, then you can do PLDM or NCSI over that. It seems to be there's a little industry bias, and OpenBMC would do PLDM probably, right? So, well, from an industry ecosystem, it does seem kind of more like PLDM over MTCP over SM bus is probably the easiest thing to do first.
Okay. So let's first of all write it down later on. This we said it would be optional and will be pushed later on.
Right.
Also, so if we're going to do, so what's going to happen is, okay, so I guess what I'm thinking of is that would be something we could get to. There may be difficulties getting to that initially, right?
To what initially?
Well, so because we're doing a hold of PCIe enumeration, right? That's if you need communication before PCIe enumeration, that can be challenging.
But if
But
I do it
I
after
don't-
the PCI enumeration, before I do the get boot status, because I will need to all the enumeration and then wait for the get boot status to be available anyway. So
Yeah. It just implies that if you're going to do PCIe VDM later, you're going to end up in a multi-session kind of thing.
if I'll do what again? Come again? Last sentence?
So if later on, because PCIe VDM, the endpoint definition is defined by, kind of, I think it's related to the BDF structure, right?
Mm-hmm.
So if you're doing MTCP before that, then you have to base it on something that's not PCIe, right?
Yeah, that was understood. Yeah. So
then if you use it later, you're going to end up with multiple sessions for a single device. I mean, I may be saying that wrong because this is not necessarily my first area of expertise, but
you're in good company. Okay, so at least I think that another thing is that we can remove that side note and just say that we will use PLDM for the short term. We will use for the immediate term until USB with more what is the right word? Not stable, standardized. I don't know.
Well, what you might want to say is like MTCP over SM bus would be required, and then the other ones would be optional.
Mm-hmm. Okay, I like that phrasing.
That's generally how we say things that are today and for a future date.
Yeah, are we trying to separate the protocol from the physical transport? And I think it may be necessary to do that.
Yeah, I mean, if you say PLDM over MTCP, it doesn't, yeah. And
why do we need to separate the two?
Well, we can specify the physical transport as being I²C, and then the protocol that runs on top of that will be PLDM.
Or you could just specify the top level protocol and not specify.
And not specify anything other than that. So you're basically saying remove that line altogether and let the server vendor decide.
Well, the protocol has to be a common protocol that both the server vendor and the DPU vendor agree upon. And we don't want every server vendor, DPU vendor couple pair to have to agree on a different protocol. We should all agree on a standard protocol. Because I don't want to write a different protocol for every different DPU that's out there, right? For my BMC.
Okay, but on the physical connector, you say that this is something that we don't need to standardize on and just let.
No, we need to say that the current is like Lee was saying, it's SM bus. Or I²C, but just have a note in there that this could evolve to higher speed technology such as USB over time. We don't want to lock it down at I²C forever, right?
Okay.
Yeah, the other thing with SM bus, right, is because it's muxed, it's not, it's real hard to do asynchronous communication unless you have another wire that's dedicated for an interrupt, right? So you end up with, you have to poll, right? So the BMC is going to end up polling this device for status. So give me status, give me status, give me status. Or presumably once you get to something like USB, it would be hubbed or switched, and then you could have asynchronous communication coming back the other way. And in which case, yeah.
Does that sound better?
Yes.
Great. Let's get back to the readable one. Okay, now when we talk about the get status in PLDM, so internally I need to take it up with Yuval to get how he views it basically and what he wants to promote here in PLDM. I'll try to set a session with him this week to come with conclusions for next time. But let's try to go over the definitions that are already here from PLDM, from the PLDM standard that are already existing. Now, the thing is about get boot status list, when I started thinking about it, is it really depends. I mean, depends on what we want to achieve here. When do we want to stop the whole enumeration? Sometimes we would want to wait for the software of the DPU to actually be running, or a certain condition on the DPU to be actually be met. For example, we have an application on the DPU or something running there and we want to wait for it to complete. Mm-hmm. Other times we may want to continue the enumeration way earlier because that process can take time and can stall the whole boot of the server. Mm-hmm. And that's not always required. Mm-hmm. So I was thinking to myself,
get another and I didn't find this in the state set spec. It would be nice to have a service object, right? That would have a running state, not running. So you could, if you wanted to optionally, so you have the so really like here on set ID 196, right? When you hit state 21, all you know is that you're leaving, UEFI, right? And going into the OS, right? And then I think there was one for like OS status where you'd be running versus terminating, but you don't know.
Let me, I have it open here.
Yeah, so you kind of look at software termination status and you, okay, I'm normal, so I must be running. It's not a great thing, right?
Yeah, I'm trying to think about things that are maybe a bit more specific. I'm thinking to myself, maybe we should do like network ready, storage ready, things like that, or we want to keep this more abstract and aligned to the existing one.
So I think at that case, so here's my mind. What you want is ultimately you want something almost like systemd status, right? But to do that, you can declare as many service objects as you want, right? And then they all have independent state, and then whatever service objects you care about, you can wait for those to become, running.
Okay, so that's right. What you're saying. we want to define in PLDM a service object a device can declare multiple services.
But also what you're saying is also valid, which is, I can't remember what in systemd they call that, but it's the equivalent of run levels, right? So you can say like, system gets to network up, then it gets to, single user, multi-user, states, right? And there are different services there's different group of services that run at different states, but there are certain high level dividers,
Yeah.
right?
So basically we are saying a bit of both. We're saying let's divide the boot into stages. In each stage we will have a set of services, or maybe services that will declare themselves in which state they are relevant in, and each service will declare will be able to report its own status. I'm just thinking if this is too abstract, because it provides a lot of flexibility, but at the end of the day, the server vendor will need to have logic on how to handle all those different entities, let's say, because you will need to check if you
Yeah.
are on this stage, then what are the services that are running and what are their status? Do
Well-
I care? Do I don't care?
So I think what I had to go back and read the systemd documentation, but as I recall, like you can tell what of those high level states, which one you're in, whether you're getting to network ready or you're getting to single user ready, multi-user ready, right? So you can just like the old initd had different run levels, that you can determine which run level you're at, or if that run level has been satisfied, I think. So it may need a little work, but the advantage to that is those things are kind of well defined. They're like standard best practice, right? Like if I'm writing a service, on Red Hat and I want to port it over to Ubuntu, I can say wait for whatever that level is, and it has the same meaning in both, contexts, right? So as long as we're talking like Linux running on a DPU, then those kind of things should probably be well.
But how important is that for the boot sequence? I mean,
There's one nasty use case of I want to boot from an emulated NVMe device, right? And to support that, it would be nice if the BIOS can not specify or not look at boot devices until that service is running, right?
But as a BMC, I for the boot sequence of the card booting up in the server, my primary concern is the PCI manager up and running, right? Can I, kick off my bus numeration? That's the primary thing,
Right.
but I'm hearing you say that there are other checkpoints after that may be interesting to the BMC, but I'm not getting it.
So I guess I'm thinking about the use case specifically of like a DPU standing in between NVMe over fabrics and emulating an NVMe device to the host, right? And in that case, it would have to have, I mean, I probably wouldn't care about all the intermediate states. I'd want to be at all services up and ready,
Yeah, that's probably like an OS running, and then not only OS running on the DPU, but XPU, sorry. But the actual software on the OS has started, finished its work, and is reported status okay. So the mechanism between the DP within the XPU doesn't really matter. Just the fact that we can report it back to the host. Now, regarding the NVMe, maybe I'm saying something very stupid here because this is really out of my element. But isn't the driver on the host? Wouldn't the driver on the host, if I want to boot from this, it couldn't detect it? Wouldn't we have like a retry period or something like that?
Well, so if you're emulating PCIe endpoints, right? And if there's a software entity that's creating them, right? Then if you don't hold off the enumeration, you end up with hot plug events, which are not always best handled, and you can't, so you're going to do the enumeration once, and then you're going to decide what your boot targets are, right? So you have to have the devices in place before you do that. That's as I understand.
To avoid the hot plug event.
Yeah, and to just have it show up as a boot target, right? Because, well, what you could do is you can kind of try and short circuit the system where whatever creates the PCIe devices creates those as early as possible, right? And then as you try and query the thing, it just keeps saying device not ready, device not ready, device not ready. But, ultimately you need to make sure that before you do PCI enumeration, all the PCIe devices need to be in place, right? Because otherwise you don't even, it's the PCIe, it's when you enumerate the bus that you even see which PCIe devices you need to load drivers for, right? And then once you load the drivers, then the driver can talk to the device and decide if it's ready or not and should be a boot target.
Yeah, I'm still not getting why we need to have multiple. We need to know when different services are ready, as opposed to having an umbrella global ready.
Yeah, that's fine too. Yeah, I was just trying to come up with a generic way to do that, and it would have incremental things, which would only be really important for debugging, right? Not for
right.
Because for the part, you're gonna just say, "Hey, wait till everything's up, and then let it go," right?
Yeah, and I think Gal makes a good point in terms of what's the burden to the BMC for knowing all of this information. I think I'll have a hard time selling this to management.
Yeah,
I think I'm okay with whatever everything is fine, but everything is fine is after OS boot, even after OS start probably, and it leaves it to the hands of the DPU vendor, I guess, to decide what is everything is fine and how it is configured, because everything is fine is one thing if I'm emulating an NVMe, and is another thing if I'm doing some networking thing or setting up a firewall, or I don't know what.
yeah. So you get into other, so where you need it may need it a little more granular, right? Is if you're booting into, if there's any kind of mode where you're going to configure the XPU, where you want to boot into another OS, or you boot into UEFI and then you talk to it, right? In which case the state might be different, right? Because it won't have all those services running, but that's fine. You're not trying to boot to it. You're trying to configure it, or you're trying to,
Mhm.
do a firmware update of something, or you're trying to do something else, right?
Yeah, actually, that comment there, Lee, brings up another important point, and that is in the boot sequence, the BMC telling the DPU what's the boot path or what's the boot option, whether it's booting up to do some maintenance work such as firmware upgrade, or booting to if there are multiple OS boot paths, and then how do you select that? So that's that at a what do we call it, boot option or something, for the BMC to tell the XPU what's the boot path, right? Or what's the boot option?
And that gets into all unfortunately, that goes back to the composition, system composition, and where the trust barriers are drawn, right? You have to have this boot coordination, and the fact that the BMC, you're assuming the BMC has control of power, right? And can control the host boot progress, right? So that's why we're talking here. Is the platform BMC or the BMC and the host managing the DPU, its configuration in boot or not, right? And so that's two different kinds of use cases, right? Based on trust. So if you're doing kind of a bare metal thing, you may if the XPU has its own BMC, right, then that would be in charge of changing boot order and configuration versus the platform. So,
and we need to specify that, and not leave it open or optional. We need to clearly state that the AMC on the XPU is responsible for selecting the boot path, and the host BMC never interferes. At some point, if that has implications, other implications as well, in terms of when the XPU or the AMC on the XPU determines that it's time for a firmware upgrade, then what are the sequence of events to make that possible?
Can we really say that the server BMC would never set the boot options of the XPU if the XPU and the XPU management are the same entity at the end of the day?
We need to explore that. I think
it also.
yeah. So I think last week we decided to get rid of XPU management and just call it XPU and kind of pull those two lines together, right?
Yeah, I kept it separate because there is the possibility there is BMC or not BMC, but yeah, if I would have known how to put a square just around here in man,
yeah, well, I know how
that would be great. No, I need to look at the documentation. I haven't gotten around to it.
Mermaid's a little different than Plant UML, and I was after you do this push request, I'll try a couple things and see if I can figure out how to clean this up. But
I'm sure I'll find something in there.
Auto number on it so that we can talk about specific arrows by number as opposed.
Yeah, I guess we can.
at a higher level, I think the question is, does the BMC ever issue a command for the XPU to change a state?
So there is, yes, so if you take the reverse case of this, right? So now you think about coordinated shutdown. If the shutdown is initiated from the host, then somebody needs to tell the DPU it's about to go power off, right?
Yes.
So that's at least one case where it's hard to avoid having the BMC drive some state into the
Mhm.
XPU.
I think eventually that's where we want to get. Can we try to think about other peripherals like GPU? And I know that I'm from NVIDIA, but I'm not an expert in that part. How is that being coordinated? And if we can find some similarities here.
In general, it's kind of assumed that PCIe devices, you can just power them off instantaneously, or, you don't have to let them gracefully shut down, right?
Yeah, they
Yeah.
don't keep state.
The DPU is a special,
Right.
special part.
Because you have a file system on there that you could be,
Mhm.
logging to all the time and everything like that, right? So with the GPU, I don't really worry about it. I just reset him, right?
Let's see. I do think that Reza made a good point that basically we need to select the boot option before the boot status. If I'm looking at this diagram, because the boot status may, what you require in the get boot status may change in the boot option. If you are waiting to boot from disk, so you may care about storage ready, but not network ready, for example. So maybe we should have another phase here before that.
I'm struggling with that, from the operator tenant model, isolation, how much does the host need to know?
So, and it also comes down to how long does the firmware update take, right? Because really what's going to happen is the system's going to be up. You're going to stage a firmware update to be applied on next power cycle, right? You're going to reboot everything, okay? And then in that case, it still looks like you're coming up, but the firmware update process might be managed by the AMC, it may be managed by the firmware. There's a lot of vendor choice and all that, right?
Mhm.
And it may, I don't know. It's kind of hard to, do you just kind of blindly don't care what happens? The platform, the BMC is not caring what's going on, and eventually this thing comes back and is ready. But could there be a situation where, like, you're doing a firmware update and you need to power cycle again, and you need to get the platform BMC to actually remove power and reapply it, right? Like, it's not good enough for you to do a reset. If that's the case, then you would need some better communication back. I don't know.
Absolutely.
I think
It also needs some.
Go ahead, Toshi.
Oh, okay. I think one potential approach is to combine with the option 2. And so in this boot sequence, NVMe as an example, we just need to wait for the controller to be ready. But we don't have to wait for the device to be ready, like a volume. Then the NVMe driver later on can wait for the volume to be ready. So this could provide the service level status check, and the service level specific check can be done by the driver.
But any entity that's checking on the status would need to know if this is a regular boot, that takes, let's say, 5 minutes, or is this a boot that is a firmware upgrade and so it's going to take 10 minutes? How do we
Right, I
manage?
agree. That could be a problem. But I think the one advantage from the operator tenant separation point of view is the driver is running on the host side and it can get information from the EFI boot path or things like that.
So, Toshi, that's kind of what I asked at the beginning regarding the regarding the NVMe part. If it's not the driver that should handle this this problem, and Lee answered that in many cases the driver, when I do the get boot status, I won't have anything to boot from, whether it's network boot or driving booting from an NVMe. But you're saying that I'm just booting from disk, even if it's not, even if it doesn't exist at the moment, and the UEFI of the host where the driver lives will do the wait for the actual NVMe. Did I get that right?
I think so. I think the issue with the option 2 was it didn't address the issue for the PCIe enumeration, if I remember
Right,
correctly.
it happens after.
Right.
And I didn't know from, I'm not a BIOS guy, does PCI enumeration happen as a parallel process, or is it completely single threaded, meaning that if you hold it up on the first function, could you add devices after that and then not screw it up? I don't know if that works for all server OEMs and BIOSes, right?
We're serial. We're strictly serial.
You're strictly
right. So if we
so
use this,
it doesn't matter if I add or remove device. If I hold your progress on the first function of a device, and then I add or remove functions after that, it's not going to break it.
It shouldn't. No, it shouldn't break it because it's
Okay.
serial.
Okay, we're good. Ours may be too. I just don't know.
right. So if we use this approach to address the PCIe enumeration part, the option ROM driver approach of the option 2 is still feasible. So we could potentially use the driver to basically hold the boot sequence until the service related to the driver is available. Of course, this should restrict it to the boot sequence, the boot device. So we don't want all the drivers to hold unnecessarily, but if the driver can check the boot information and if it knows the system is booting from the NVMe, that driver can hold the boot sequence.
How does that hold in case of network, not storage? If I want to do PXE boot, and I'm waiting for storage to be set up, network to be set up by the DPU, I wouldn't see I will see the NIC because it's there as a boot option. But when I'll try to boot from it, I won't have network.
Yeah, you'd have to play games with the link status.
Well, this is an XPU we're talking about, and it's, one of its functions is to abstract that functionality, right? And so it's not like the host is speaking directly to the endpoint. It's going through this abstraction layer, and so I'm thinking it's completely up to the XPU. I don't want to tell these guys how to do their job, but it seems like the XPU should be handling that effectively.
I'm just
Because it
wondering to myself if it's still, if the driver approach Toshi is mentioning is also valid for network, because I think UEFI is too late there. Let's say it takes 2 minutes for the link to be up.
Contractually, the link has to be up faster. And most people doing network booting, you end up having people basically say, run in port fast mode, or don't have all the hold downs on the port. The challenge here is the balance between, do I have pre-populated configuration, or is the machine hunting for configuration to boot from? And one case is very easy, the other case is harder, of course. You're having to hunt for a PXE target versus, oh, the configuration entry you had to boot with tells you where to boot from. You don't necessarily know when you're network booting. And technically, if you have an emulated NVMe target, you may not necessarily know other than the device. It could be that the firmware is trying to boot off of the default path for bootloader based upon architecture.
Okay.
One question. So there is the hold PCI enumeration. So it's like similar question that I had before. The network card can be PCI card. So if you hold the PCI enumeration, it will not be able to find network card and will not be able to load the driver. So on this picture, is that reasonable to say do initial PCI enumeration, which will collect the available devices and load the drivers, and then hold the boot until the DPU will come up, and then update the enumerate like a PCI enumeration information with additional data. So in general, it will allow to load all drivers like a video network stuff by the UEFI, and then you can hold until the DPU will come up and then re-enumerate the PCI devices. Does it make sense?
I think you said it a lot, and I wish you said it earlier, because I would have had time. I think we would have time to discuss it. But can you put a pin in that? Because you said a couple of things that are important. That you started with that the XPU can be just a network device and doesn't need that whole, maybe it won't even have that all update boot status and all that going on. But we are already out of time, and I know that in a second people are going to drop. Can you try and put a pin in that, and let's get back to it in a week or two when we go to the coordination? I'll try to put it in the meeting notes. The meeting is also recorded, and I'll go over it and write it down. Next week, I wanted to shift a bit to the to open the Redfish topic that we start talking about when Julia talked about OpenShift, OpenStack. So this is also something that we wanted to start a conversation on how to standardize. Julia, do you think that you'll be able to provide us with what you're doing at the moment and require right now at OpenStack, or what you're hoping to get? And that would be like a baseline to start from? Julia?
Sorry, fighting Zoom. I can tell you guys exactly what we do. It's pretty straightforward. I did notice,
like the Redfish schemes that you are using, or what you would prefer to use, just to start the conversation.
Yeah,
Yes.
that's easy. That's super easy. I just have to sit down and pull it up.
Perfect. So for next week, let's open this topic and let's try to have those two things in parallel, because I think that on the boot sequence, at least, I know that I have a lot of homework to do internally with what can I talk about, what are our approaches, what we should and shouldn't do. And if there are other DPU vendors still on the call, I think it would be great if you do the same. Mostly the server vendors talk today, so Pensando, Intel, I don't know who else on the call. If you can do some house to check in house, if you can talk, want to talk about those topics. I think it would be nice to get your point of view on this one as well.
Sure, Gal. I'm listening, and I didn't have too much strong opinions, but I will certainly vet this proposal with the team.
That would be great. Again, no pressure. What you can or can do, but
certainly no. I think we'll try to align and see if there is any gotchas with this.
Okay.
Thanks.
Yeah,
Good to know.
same thing from Marvel side as well. There was nothing that was conflicting, so we were also listening.
Good to know. Okay, folks. Then see you in a week.
Yeah. Thank you.
Thank you very much. Have a great rest of the day. Bye-bye.